Hello friends, in this video I'd like to solve the following problem from the Balkan Mathematical Olympiad 2022, shortlisted problem A1. So this problem was not actually given the competition, but it was considered to be given. And by the way, I don't know the origin of this problem, because in other words, I don't know from which country, I don't know the author of this problem, and I don't know their country of origin. If you happen to know from which country or which country proposed this problem, please let me know in the comment section. Thanks. So, we wish to find all functions f from the set of real numbers into itself, such that f of x squared plus x times f of y equals x plus y times f of x for all real numbers x and y. So it's a rather simple problem. Here are my hints. First, consider the case when our function is constantly zero. And then, suppose that our function is not constantly zero, so for some real number f of x0 is not zero, and show that in this case our function f must be injective. And after establishing injectivity, just set y to be y1 minus x, using the injectivity to find the formula for f. And also, along the way, to establish injectivity, the following fact may be useful, that if we have the composition of two functions, which is injective, then the inner function must be injective as well. So give this problem a try, and I will see you in just a minute. Right, so as I said, notice, let's maybe write it. Notice that our function, which is constantly zero, satisfies our equation. Obviously, because here we have 0 equals 0. So that was easy. So now suppose that f of some number is not 0, or some real number x0, and let's set x to be x0. We have the following: f of x0 squared plus x0 f of y equals x0 f of x0 plus y times f of x0. And now let's look at this equation. The function right here, the function which takes real number y and maps it to x0 f of x0 plus y times f of x0, this function is bijective. But we only need injectivity, so let's write that it's injective. Why is that? Well, because it is an affine function, which is not constant. It's a affine non-constant function, because it is affine and non-constant. So that means that the function which stands on the left-hand side must also be injective. Let's write it maybe in different color. That means that function which takes real number y and maps it to f of x0 squared plus x0 f of y is also injective. It's also injective. But here we have a composition of two functions, so the inner function must be injective. So the function which takes a real number y and maps it to x0 squared plus x0 f of y is injective. And that means two things. First of all, x0 cannot be 0. So x0 cannot be 0, obviously. And, well, f must be injective as well. And function which maps real number y f of y is injective. It's very easy to verify it. So let's write it. We have established that f is injective. Maybe let's don't write it. So now this fact is crucial. Our function is injective. And now let's go back to our original equation and let's set y to be 1 minus x. Then we have the following: f of x squared plus f of 1 minus x, because instead of y we have 1 minus x, equals, well, x plus 1 minus x f of x. So we have f of this number equals f of x squared plus x f of 1 minus x equals f of x. Now, by our injectivity, we can actually cancel the outer occurrence of function f. So by injectivity of f, by injectivity of our function, we know that x squared plus x f of 1 minus x is x, which means that x f of 1 minus x is x 1 minus x, and we can divide by the x, of course, if it's not 0. So for x not 0, we have the following: f of 1 minus x equals 1 minus x, i.e., after shifting our variable, maybe let's write it right here. For every non-x which is not 1, f of x equals x. So our function is almost identity, but what about f of 1? How can we find f of 1? Well, to find f of 1, let's set x to be 1, and let's set y to be 2 in our equation, in our functional equation. And we have the following. On the left-hand side, let's go back. Let's look at our equation. This one, x is 1, y is 2. So we have the following: f of 1 plus f of 2 equals 3 times f of 1. But we know that f of 2 is 2. So we have f of 3. f of 3 is 3. So 3 equals 3 f of 1. So f of 1 equals 1 as well. And after combining this and that, we see that in fact, for every real number x, f of x is x. So we have only two possibilities, our solutions. So solutions. Either our function is 0 for all real numbers, or our function is identity for all real numbers. For all real numbers. And of course, we have to do verification. Function which was constantly 0 has been already verified, but what about the other function? Well, verification. Well, verification. Left-hand side. On the left-hand side, we have f of x squared plus x times f of y. So it's x squared plus xy, and that happens to be x plus y times x. So it's x plus y f of x, which is on the right-hand side. So all in all, we have just two solutions. And that closes our problem. Thank you very much for watching, I hope that you've learned something new this time, and I will see you next time. Goodbye.